Hello and welcome to lesson 49 of Additional Maths with Mr. Barrow. In this lesson, I'm going to go through questions 1 to 10 of the June 2019 OCR paper. Make sure that you have tried that paper and those questions before watching this. In the next lesson I'm going to go through the questions after question 10, so questions 11 onwards. But I'm going to go through questions 1 to 10 in this video, okay, which is 50 marks worth. Okay, so these papers come with this formula sheet. There's only 1 or 2 questions which actually require it. And in fact, if you have learnt the syllabus well enough, you shouldn't need to use these formulae at all. They should be well ingrained in your psyche. Okay, so without further ado, let's have a look at question 1. So in this question, it says a committee consists of 5 people. Okay, the roles of chairman, secretary and treasurer are to be allocated at random from the committee, with no one person taking more than one role. In how many ways can this allocation of roles be made? Okay, I'm thinking, as soon as it's talking about the number of ways in which we can make a sort of committee, I'm thinking about, is this combinations or is this permutations? Okay, now this committee, we're trying to choose 3 types of people: chairman, secretary and treasurer. Okay, so we're not just choosing a committee of 3 people from the 5, in which it wouldn't matter the order. Here we're choosing specific roles. Okay, so it matters who we choose as chairman. It matters who we choose as secretary. It matters who we choose as treasurer. So this is talking about permutations. In fact, the easiest way to think about this is there are 3 roles to be filled. Okay, so I've got my 3 roles there. So this role is the chairman role. This role is the secretary role, and this role is the treasurer role. Okay, so first I'm looking at these 5 people that I want to choose for my chairman, secretary, and treasurer. Firstly, I'm going to choose my chairman. So from the 5 people, how many different chairmans can I choose? Well, there are 5 different possible options from the 5 people. Okay, once I've chosen the chairman, the secretary can be chosen from 4 people. So there are 4 choices left. And once I've chosen the secretary, I've got now 3 choices for the treasurer. So this is 5 lots of 4 lots of 3, okay, which is 60 different possible options for ways in which I can choose these 3 roles from 5 people. The other way of doing this would have been, this is permutation. So if I use my calculator, I could have simply typed in 5p3. That means how many ways are there, how many permutations are there of 3 people chosen from a total of 5. Okay, and that also would give me 60 on my calculator. Let's have a look at the mark scheme for this. So the mark scheme, similarly, it talks about 5p3, or it talks about 5 times 4 times 3, or it talks about this 5 factorial over 2 factorial. 5 factorial over 2 factorial is just simply the taken from the formula for permutation. So NPR is given as n factorial over n minus r factorial. So here it will be 5 factorial, because I'm doing 5p3, be 5 factorial over 5 minus 3, which is 2 factorial. So this bit here is just using the calculation for NPR. But I like the 5 times 4 times 3 way of doing this, the simplest way of thinking about it. If you need more work on this, have a look at lesson 21 on my channel about permutations. Okay, let's move on to question 2. Remember, before I go through the questions, make sure you've had a go at it yourself. Okay, question 2a. Solve the inequality x squared minus x minus 12 is less than or equal to 0. Okay, so this is a quadratic inequality. When I solve quadratic inequalities, I always like to sketch the graph of the quadratic function first. Okay, so the quadratic function I'm dealing with is here. And I want to sketch the graph of y equals x squared minus x minus 12. That will help me decide when x squared minus x minus 12 is less than or equal to 0. In order to sketch quadratic, having the roots of that quadratic are useful. So if it factorizes, that will help us get the roots really easily. And this factorizes really nicely. So x at the start of both brackets. And I know that 4 times 3 is 12. And if one of them is negative, then I'll have negative 12 as the product. And if I want minus 1x, then x plus 3, x minus 4 would expand to make that quadratic. Because 3x and minus 4x will combine to make minus 1x, and 3 times negative 4 will make negative 12. So that's the factorized form of the quadratic function. So that will help me sketch it, because now I know the roots of that quadratic function. I know the roots of the quadratic function are negative 3 and positive 4. Those are the values that would make the y coordinate 0. So I know it's going to be a positive quadratic because it's positive x squared. So it'll have this shape. And I know the roots are negative 3 and positive 4. So I know that negative 3 is there and positive 4 is there. So what I've drawn there is I've drawn a very basic sketch. I haven't even included the y-axis because that isn't important here. I've just shown that the x-axis, that this quadratic goes through the x-axis at the points minus 3 and 4. And it has that positive parabola shape. So the next thing I want to do is I want to look at this quadratic inequality. This quadratic inequality states that it wants to solve when x squared minus x minus 12 is less than or equal to 0. Now, since I have drawn the graph of y is equal to x squared minus x minus 12, I'm in essence trying to solve when y is less than or equal to 0, because I have drawn the graph where y is x squared minus x minus 12. So if I replace x squared minus x minus 12 with y, I have the inequality y is less than or equal to 0. So in my graph, when are the y coordinates on that graph less than or equal to 0? And that will be in these highlighted bits here. So those parts there, that part of the graph, the y coordinates are negative. But I want to know when the y coordinates are negative or equal to 0, so that it would include the minus 3 and the 4. So anything between minus 3 and 4 inclusive will solve this inequality. So that would be written like this. Minus 3 is less than or equal to x, which is less than or equal to 4. That in essence means the values of x could be between minus 3 and 4, including minus 3 and 4. It's anywhere in this region there, those x values that are included in that green section there will make the y coordinate of my quadratic negative or 0. Okay. Part B is just illustrating this answer to part A on the number line provided. So it's thinking back to your GCSE, do you understand how to show the solutions to an inequality on a number line? And if it's between minus 3 and 4, we put a bubble above minus 3 and a bubble above 4. If it includes those, we fill in the bubbles, and it includes both minus 3 and 4. So we fill in that circle, we fill in this circle, and we join them to say it's anything between those as well. Okay, so let's look at the mark scheme. And it just shows you how you can get the marks. If you've done factorizing but not very well and got the wrong positives or negatives, you can still get method marks. And yeah, those are the only ways that it shows. It doesn't talk about the graph, but I think the graph really helps you decide that. So if you want more work on this, have a look at my lesson 7 on quadratic inequalities. Okay, question 3. Find the equation of the normal to the curve y equals x cubed minus 2x squared plus 2x plus 4 at the point 2, 8. Okay. So we have a curve, and I want the equation of the normal. The normal is a straight line which is perpendicular to the tangent. Okay. So it is at right angles to the tangent to the curve. So let's try and see if I can sketch it to show what it is I'm trying to look for. If I sketch the graph of this cubic, this is a really bad sketch, I apologize, but all we need is a general sense. Okay, so there's my x and y axes. My sketch, I know it's going to go through 4 on the y-axis, so it might look something like this. Okay, so there's my general cubic. Okay, going through at 4. And 2, 8 will be somewhere over here. Okay, so that point there. I want the equation of the normal to the curve at that point. The tangent to the curve at that point will be this blue line that just touches the curve at that point. So the normal will be at right angles to that. So it'll be, apologies, it'll be something like this. Okay, so it'll be at right angles to that tangent. In order to find the equation of a straight line, I need 2 pieces of information. I either need 2 coordinates, and using those 2 coordinates, I can then find the gradient and things like that. Or I need the gradient and 1 other coordinate. Here I've just got a coordinate. However, using the miracle, the wonder of calculus, I can find the gradient. I can find the gradient of the curve at any point by differentiating. Okay, that is a process within calculus. If I differentiate the curve, y equals x cubed minus 2x squared plus 2x plus 4, that will give me dy by dx is equal to x cubed differentiates to 3 lots of x squared because the power drops down in front and then the power drops by 1. Minus 2x squared will become minus 4x to the power of 1. And then 2x will become plus 2. The number 4 differentiates to 0. So this here, dy by dx, is my gradient formula. That is the gradient of the tangent to the curve at any point on that curve. So if I wanted the gradient of the blue line, so the gradient of the tangent will be the value of dy by dx when x is 2, because I substitute this value, x is 2, for the point where the x coordinate is 2. So the gradient of the tangent will equal 3 lots of 2 squared minus 4 lots of 2 plus 2. Okay, 3 lots of 2 squared is 3 lots of 4, which is 12. So it's 12 minus 8 plus 2. So that is 6. So the gradient of the tangent, so this gradient is 6. If the gradient of the tangent is 6, then the gradient of the normal, since the normal is perpendicular to the tangent, it has a gradient which is the negative reciprocal of the tangent. So the negative reciprocal of 6 is minus 1 over 6. So negative a sixth. Okay, so now I have the gradient of the green line and I have a coordinate that is on the green line because the tangent and the normal both go through 2, 8. So I know that I'm going to use y equals minus a sixth x plus c will be the gradient, will be the equation of this green straight line. I also know that since it goes through the point 2, 8, that when x is 2, y will be 8. So I'm going to replace y with 8 and x with 2 in order to try and find the value of c. So 8 will equal minus a sixth times 2, which is minus a third, so negative a third, plus c. And so c will equal, if I add a third to both sides, 8 and 1/3. Okay, so my equation of my normal will be y equals negative a sixth of x plus 8 1/3. If you prefer improper fractions, which I do, then it would be even better as y equals negative a sixth of x plus 25 thirds. And if you prefer equations of straight lines with no fractions, which I do, then you would multiply everything by 6. You would get 6y equals negative x plus 50. Or 6y equals 50 minus x. All of those there are correct because we haven't been asked to write our equation of arm normal in any specific way, so any of those would get the final mark. Okay, let's have a look at the mark scheme. So here they just ask you to differentiate, plug in the value of 2 to get the gradient of the tangent, then use that to get the gradient of the normal, and then they used a slightly different method. I used y equals mx plus c and then substituted 2,8 in. They used y minus y1 equals m lots of x minus x1. And if you want more information on that, I think that might be within my lesson 37. It's up to you which method you use. Okay, so if you need more practice on this, go and see lesson 37 on equations of tangents and normals. Okay, let's have a look at question 4. On the grid provided, sketch the curve y equals 1/5 multiplied by 2 to the power of x. So this is an exponential function because the unknown, the input, the x value, is in the exponent. Okay, it's in the index. It's 2 to the power of x. So if you know your exponential functions, they generally look like this. So they will rise from the x-axis. If the base is greater than 1, then they will rise like that. If the base is between 0 and 1, then it'll be exponential decay rather than exponential growth. Okay, but this one is exponential growth because it's 2 to the power of x. So sketch that curve. Now I could just do a table of values, x values and y values for this, and go between -3 all the way, -2, etc., all the way up to 6, and plot the values of y for each one. Okay, so calculate the values of y for each one. So the first one would be 1/5 times 2 to the power of -3, because if x is -3, then you simply replace that value, that x, with -3, substitute that in, and find the value of y. So 1/5 times 2 to the power of -3, which would be 1/5 times 1/2 cubed, which would be 1/5 times 1/8, which is 1/40 or 0.025. And then the next one will be 0.05, then the next one will be 0.1, 0.2, 0.4, etc. Each time, as you go one increase in the x direction, it will double in the y direction. So that would look something like this. So it would be very close to 0, a tiny number for -3, another tiny number for -2, tiny for -1. At 0, we are only at 0.2, which is about there, because these grid lines are going up at 1, 2, etc. At 1, we have 1/5 times 2 to the power of 1, okay, which is 1/5 times 2, which is 2/5, which is 0.4, which is about there. Then at 2, we have 1/5 times 2 squared, which is 0.8. Then it starts increasing at a more visible rate, although at every single stage it is doubling. It's just starting at a very small values towards the left. So then 3 is 1.6. At 4, when you substitute it in, you get 3.2. At 5, you get 6.4, which is about there. And at 6, you get 12.8, which is off the screen, about up there. So if I then sketch the graph, I just go through these values really badly. And we have our graph. Okay. So that's part A. On the grid provided, sketch the curve. Part B. Solve algebraically the equation 1/5 times 2 to the power of x is equal to 3. Well, if I was asked to solve geometrically, that would mean using the graph, or solve graphically, that would mean using the graph we've got. And that would mean saying we've replaced y with 3. So it's saying when y is 3, what's the value of x? So here's 3 in the on the y-axis. So it's asking for what this value of x there is. And I could estimate it. It's about 3.8 or 3.9 or something like that. But it's asked me to algebraically solve this. Okay, so we're going to solve it using the way we solve exponential equations, which is using logarithms. So firstly, I'm going to write down that equation. A fifth times 2 to the power of x is equal to 3. Okay. So firstly, I just want to know what 2 to the power of x is equal to. So I would divide both sides by a fifth, or in other words, multiply both sides by 5. So 2 to the power of x would be equal to 15. Since a fifth of it is 3, then it itself is equal to 15. And now at this point, I have a very simple exponential equation. And if you understand what logarithm is, then the next step will just get you the answer straight away. If 2 to the power of something is equal to 15, then that something is equal to the logarithm to base 2 of 15. The definition of log base 2 of 15 means what power of 2 gives me 15. That is simply what it is. It's just another way of rewriting this expression in another way. Those two statements are equivalent statements. But my calculator is set up so that I can solve this now, and I can simply type it into my calculator so it looks exactly like that. So log base 2 of 15, if I type it into my calculator, gives me 3.91 to 2 decimal places. So 3.90689 ... Now, what's it ask me? It says giving your answer to 3 significant figures. Okay, so this to 3 significant figures, cutoff point would be there because the third significant figure is that 0 digit. So the 6 after that cutoff point is high, so the 0 rounds up to 1. So this is equal to 3.91 to 3 significant figures. So my estimate from my graph was pretty accurate. I said 3.8, 3.9, and it was actually 3.91 more accurately. So let's have a look at the mark scheme. So my graph isn't quite as nice as this, clearly because this is computer generated, and I used my artistic abilities to try and draw a smooth curve appallingly, but there we go. And part B, it gives another way of solving it here using the laws of logarithms, but I prefer just knowing what a logarithm means and going straight from 2 to the power of x is 15 to log base 2 of 15 is equal to x. Okay, so if you want to practice exponential graphs, that will be lesson 26. And then if you want to solve equations, then it's lessons 27 and 28. Okay, let's have a look now at question 5. Aha, logarithms. So this follows on quite nicely from question 4. And this is all about, you have to solve this question, solve the equation log base 10 of x plus log base 10 of x plus 2 is equal to 3 log base 10 of 2. And we must show detailed reasoning. So we can't just write down x is equal to this because we have a fancy calculator that might be able to solve this type of thing. We need to show the steps in our working to show where we've got our solution from. Okay, so looking at this, I'm thinking, well, I know, using my logarithm laws, that I know the following things. I know that if I have log of a plus log of b, I know that is equivalent to log of ab. And the left side of that equation has that very thing. So the left side of that equation, log base 10 of x plus log base 10 of x plus 2, can be combined into one logarithm, which would make things simpler, as log base 10 of x multiplied by x plus 2. Okay. The right side of that logarithm equation, 3 log base 10 of 2, well, I know that if I have n log a, this is the third logarithm law, then that can be written as log of a to the power of n. So 3 log base 10 of 2 can be rewritten as log base 10 of 2 to the power of 3. Okay, which is log base 10 of 8. So on the left hand side, I've got log base 10 of x squared plus 2x. I'm just expanding those brackets. And on the right side, I've got log base 10 of 8. Now notice something. On the left side, I've got log base 10 of this thing is equal to, on the right side, log base 10 of this thing. So those two things must be equivalent. They must be equal to one another. So my next line will simply state that x squared plus 2x has to equal 8. So when you're trying to solve logarithm equations, it is useful often to simplify the logarithms into one single logarithm. And then if you've got logarithms on both sides of the equation, if log of something equals log of something, then the two somethings must be equivalent to one another. And this now is a simple quadratic equation which I can solve. X squared plus 2x equals 8. When I solve quadratics, I need to make sure it is equal to 0. So x squared plus 2x minus 8 is equal to 0. Now, can I factorize? So x plus 4, x minus 2. So my solutions are x is negative 4 or x is 2. Now, I need to think, do these solutions make sense for the question? I need to be able to substitute them back into the original and state that they work. So are both negative 4 and positive 2 possible solutions? Well, if I try and substitute negative 4 in as x, I will get log base 10 of negative 4. Now, that is saying what power of 10 gives me negative 4. You cannot put 10 to the power of anything that will give you a negative result. Since 10 to the power of very negative numbers give you 1 over 10 to the positive power, which is still slightly above 0. You will never get, it'll be an exponential, like I showed before, where it'll rise like that. So this is y equals 10 to the power of x. This is what it'll look like. So as we go further and further negative values of x, we'll get closer and closer to 0, but still not touching it. So at no point will there be negative values for that exponential. Therefore, there are no powers of 10 which give you negative 4. And so this is not a solution. So we cross that out. We must make sure we cross that out. If we don't, we lose a mark. We have to state x is not equal to minus 4. So x is equal to 2 is our only solution to this. Okay, and let's have a look at the mark scheme. And as it shows in the mark scheme, it shows that you have to state x is not equal to minus 4. Okay. So it says reject minus 4. So you have to make sure you have stated that you reject minus 4. Okay. It's also got a beware. It looks like you can get the right answer with really bad workings. Okay, just luckily. So just avoid that. Make sure you are careful. Show detailed reasoning. Okay, the answer is not the key. It's the detailed reasoning which is the key. If you want to practice logarithms, see my lessons 27 and 28. Okay, let's have a look at question 6. So here is looking like a trigonometric question. So angle theta is such that tan of theta is 1.5. Find the two values of theta in the range 0 degrees to 360 degrees. Okay, when I'm trying to solve a simple trigonometric equation and find various values that work in a certain range, I like drawing the graph of that function. So I'm going to draw the graph of y equals tan of theta. So tan of theta, so I'm going to draw it in green, looks like this. You should make sure that you have memorized how to sketch the graphs of sine theta, cos theta, and tan theta. So there are, on the lovely tan graph, there are asymptotes at 90 and 270. So we only want to go up to 360, so I don't really need to go any further, although just for completeness sake, I will continue that graph. So we're looking at just the parts which I have highlighted here. Okay, so those are the graph between 0 and 360. Okay. So if you try to put tan of 90 in, it would give you math error, which means that there is no value. There is no y value for 90. Okay, that's why it's an asymptote. An asymptote is a value of x for which there is no value of y. Okay, it tends towards that value, but it doesn't ever reach it. And the same at 270. Okay, those two are asymptotes. I'm drawing dotted lines to show that there is sort of like a break in the graph. It is not a continuous graph. Okay, so tan theta is 1.5. So let's say 1.5 is about there. So between 0 and 360, there are two, between 0 and 360, there are two values of theta which give you 1.5. One is there, and I'm going to call that A, and one is here, and I'm going to call that B. So my calculator will give me one of them, and I have to deduce the other one. So on my calculator, in effect, I'm solving this. So to find theta, I need to do the inverse of tan to 1.5. And I've got to make sure my calculator is in degrees mode, because otherwise it won't give me my answer in degrees. So on my calculator, it gives me the inverse of tan of 1.5 is 56.309, etc. So let's just call it 56.3 degrees to one decimal place. So that is clearly A. A is 56.3. So how do I use that to deduce what B is? Well, the tan graph repeats every 180 degrees. It is the same shifted 180 degrees in the future. So this 0 becomes 180, becomes 360. So B is just 180 degrees further on from A. So my values of theta are 56.3 or 180 plus 56.3, which is 236.3. To one decimal place, both of those. So those are my two values of theta in the range 0 to 360. Okay. In part B, it's asking for detailed reasoning. It's asking for us to find the exact value of sine theta, given that I know tan theta. Okay, there are different ways of doing this, but I'm going to try and look for the simplest way of doing this. Now, I know that theta could be either of these two values. So one might think I can just substitute those into my calculator. I can do sine of 56.3 or sine of 236.3 and get the two results. But it's asked for detailed reasoning, and that isn't detailed reasoning. So it's asking for us to use the value tan theta is 1.5 to get that. So I'm going to rewrite tan theta as 1.5 as follows. If tan theta equals 1.5, then that's the same as tan theta is 3 over 2. I'm going to draw a triangle now and go back to original trigonometry based on a little right angle triangle. If theta is this angle here and tan of theta is 3 over 2, that means I know the opposite and the adjacent sides, because tan theta is the opposite over the adjacent for a right angle triangle. So I could just say that's 3 and that's 2. Okay. Sorry for the scale of my diagram. It's not great. The 3 looks smaller than the 2, but you get the general sense. So I know that sine theta is the opposite over the hypotenuse. So if I've got the opposite and the adjacent, I can use Pythagoras to work out the hypotenuse. Okay, so 3 and 2 are my shorter lengths of this right angle triangle. So the longer length is the root of 3 squared plus 2 squared. 3 squared plus 2 squared is 13. So the hypotenuse is the square root of 13. So I know that sine theta will equal 3 over the square root of 13. Or if you don't like having a surd in your denominator, then you rationalize the denominator of that fraction and you get multiply top and bottom by root 13, you get 3 root 13 over 13. Now that is one solution. My original had in my original I had one value for tan theta, but I had two possible angles, 56.3 or 236.3. I've got to be very careful now that I don't just assume that this is the only answer, that sine theta can only be 3 root 13 over 13. Because if I drew the graph of sine theta, okay, so I'm going to draw the graph of sine theta. I'm going to draw it in red on top of this graph here. Sine theta between 0 and 360 will look like this. If my angle is A, okay, so if A is the angle 56.3, my value of sine theta will be positive. Okay, and I've just proven that that value there is 3 root 13 over 13. However, if my angle is B, then my value of sine of B is going to be negative. And since this is symmetrical, it'll be the symmetrical value to 3 root 13 over 13, which is negative 3 root 13 over 13. So my two solutions would be 3 root 13 over 13 or negative 3 root 13 over 13. So you've got to be careful and just check that for the angles that you're given for theta, that your answers to sine theta might all be positive, but there might be one positive, one negative. Okay, so I've got two solutions here. Let's have a look at the mark scheme. So yeah, so sine theta is 3 root 13 over 13 or minus 3 root 13 over 13. Okay, there is an alternative method which I'm not going to go into, but you can have a look at more deeply, which involves the fact that tan theta can be rewritten as sine theta over cos theta, and you can use the fact that sine squared theta plus cos squared theta is equal to 1. Okay, but it seems a more difficult way of solving this. If you want more work on this, I've done lessons on trigonometric equations and trigonometric identities, and so trigonometric equations 1 seems to be helpful, so that's lesson 14, and trigonometric identities, which is lesson 16. Okay, let's have a look at question 7 now. So in this question, we need to show detailed reasoning. Again, it's question 7. The equation x cubed minus 3x plus k equals 0 has a root x equals 2. Okay, so that means there is a solution. X equals 2 is a solution to this equation. If I have a solution to the equation, then I know if I substitute 2 in, it will solve that equation. Okay, so it will work when x is 2. So I'm going to substitute 2 in. So I'm going to find f of 2. Okay, so f of 2 should give me 0. So if I plug 2 in on the left, it should equal 0. Okay, because this equation equals 0, it says so. So f of 2 gives me 2 cubed minus 3 lots of 2 plus k. And that should equal 0. So 8 minus 6 plus k equals 0. So therefore, k is 2. Sorry, k is negative 2. Okay, so I've got the value of k. So I know my equation is the equation x cubed minus 3x minus 2 equals 0. I need to find the numerical values of the other roots of the equation. So this cubic Now, I know already one of the roots. If I know one of the roots, then by the factor theorem, if x equals 2 is a root, then that implies that x minus 2 is a factor. So if x is 2 is a root, then x minus 2 is a factor of the polynomial. So I could divide this by x minus 2. Or factorize it with a factor of x minus 2. So I know it is a cubic function. So therefore, if I divide by a linear, I will have a quadratic part there. So a linear times a quadratic will give me a cubic. So I'm going to deduce what that quadratic part is. So I'm going to divide x cubed minus 3x minus 2 by x minus 2. Okay. I like using the grid method of doing this. I like deducing what the quadratic will be that multiplies by x minus 2 to give x cubed minus 3x minus 2. The top left part is going to be x cubed. And the bottom right part is going to be minus 2. The rest I can try and fill in. Okay. X times what gives me x cubed? Well, I know that's going to be x squared. Now I'm going to start filling things in. So x squared times minus 2 is minus 2x squared. How many x squareds do I have in my cubic? I have, there are no x squareds here. Okay, it's like it's missing an x squared term. So I need 0x squared. So I've got minus 2x squared, so I'm going to need another 2x squared to make 0x squared. So hence, this part here is going to multiply by x to give me 2x squared. So this needs to be 2x. 2x times minus 2 is minus 4x. Now let's look at my cubic. How many x's do I have? I have negative 3x. I have minus 4x so far. I need one more x to get negative 3x. So x times what gives me x? Well, 1. And 1 times minus 2, is that minus 2? Yes, it is. Okay, so good. I found my quadratic. It is x squared. It is plus 2x. And it is plus 1. Okay. So I've got my linear and my quadratic part. Now, can I factorize the quadratic part into 2 more factors so that I have 3 factors in a row and then I have all 3 solutions? And the answer is yes. I can factorize x squared plus 2x plus 1 into x plus 1 times x plus 1. So my 3 solutions are x equals 2, which I already knew, x equals negative 1, and also x equals negative 1. So negative 1 is a repeated root. Okay. So really there are only 2 solutions. If I drew the graph of this, at the point where x was equal to negative 1, the quadratic would brush the x-axis, and it would be like at negative 1, it would either brush it from above like that, or it would brush it from below. Okay. And since it's a positive cubic, I know that it's going to actually not be like that at all. It's going to brush it from below. It's going to look something like this. Since positive cubics have this shape, and they start bottom left and end up top right. So we found the other values of the other roots of this equation. So are we done? Let's have a look at the solutions. Yes, we're done. It just says minus 1, minus 1. Okay. And it says accept minus 1 written once only in answer, providing 3 factors of the cubic are seen. And we showed that. So if you want to practice using the factor theorem, that's lesson 4. And if you want to practice polynomial division, so dividing a cubic by a linear factor, then that's lesson 3. Okay. All right, let's have a look at question 8 now. Each of 5 students has a fair coin. They play a game which each student tosses their coin, and when the result of their toss is a head, then they're eliminated. The game continues with the remaining students tossing their coin again, And then any student who tosses a head is eliminated. The game continues until all the students have been eliminated or there is a single winner. Okay. So this is a probability problem. And each event is individual event is throwing a coin. And there is I'm guessing it's a fair coin. Therefore, there is a half a chance of heads, half a chance of tails. So we need to calculate the probability that, firstly, all students are eliminated after their first toss of the coin. So this one there's only one way of doing this, and this is if everyone gets heads on their first toss. So there are 5 students. So basically finding the probability of getting 5 heads. And that is a half to the power of 5. So it's heads, 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 heads. So half to the power of 5, which is equal to 1 over 32. Okay, or 0.03125. But 1 over 32 is much nicer. Okay, so that one's relatively simple. Part B, find the probability that exactly 2 students are eliminated after the first toss, and then exactly 2 after their second toss, leaving 1 winner. So in the first toss, that means if 2 are eliminated, then that means that, so first round, let's say, what we got was 2 heads and 3 tails, because 3 continued on to the second round. And in the second round, 2 were eliminated, so they're not in it anymore. So there's only 3 people in it, and 2 got eliminated and 1 was winner. So 2 more heads were gained and 1 person got tails. Okay, so it's in effect, in the first round, I've got a binomial probability where if x is the number of heads that I gain, then x could be distributed binomially with 5 trials, 5 people throwing a coin, and with each person getting a half chance of success. Okay, with each throw, half chance of success being here the number of tails that we gain. And in the second one, here let's use a different letter for the second round. So y is distributed binomially with 3 people doing the trials, and again half a chance of success. So I want to find the probability that x equals 3, so there were 3 tails from 5, and, sorry, I'll get rid of that bracket, probably that x equals 3 and y equals 1. So 3 went through from the first round and 1 went through from the second round to be the winner. So in binomial distribution, if you want the chance of getting 3 successes from 5, then it's 5 choose 3 multiplied by a half success to the power of 3 multiplied by failure, which is also a half to the power of 2, because there were 3 tails and 2 heads. Okay, so that's the chance of getting 3 tails and 2 heads from 5 throws. And that is 10 times half to the power of 3 times half to the power of 2, which is 1 over 32. Now, probability of y being 1, well, this one is 3 trials this time, because there are 3 people, and choosing 1 person to succeed, multiplied by a half to the power, so success to the power of 1, and failure, there were 2 people who failed. So that would be 3 times a half to the power of 1 times half to the power of 2 is 1 over 8. And I want both of these things to happen successively. So I want this thing, then this thing. So I multiply the 2 probabilities together. And if I've done that right, I should get 15 over 128, or approximately 0.117. So this is quite a complex application of the binomial distribution rule, if you want to do a bit more work on the binomial distribution, have a look at lesson 25 of mine. Okay, let's have a look at question 9. Okay, so sign change question. I'm talking about iteration as well. So we've got a cubic equation which has 2 negative roots and 1 positive root. So the 2 negative roots are alpha and beta, and the positive root is gamma. By considering a change of sign, show that gamma lies in the interval 0 to 1. This symbol there with the square brackets means between 0 and 1. Okay, so x is between 0 and 1. So the value of gamma lies in that interval. Okay, by considering a change of sign. So here we need to show that if I substitute some value between 0 and 1 into that cubic, it will solve that cubic. But we don't know what value between 0 and 1. So this is a very simple question with only 2 marks. All we need to do in this question is show that one of the values, if I substitute the left value 0 in, and if I substitute the right value 1 in, that there is a change in sign between them so that gamma must be between them. And I'll show you why in a second. So let's substitute 0 in first. So let's find f of 0. So f of 0 would be 0 cubed plus 2 lots of 0 squared minus 0 minus 1. And that gives me minus 1. Now let's substitute 1 in. Okay, so f of 1. So f of 1 gives me 1 cubed plus 2 lots of 1 squared minus 1 minus 1. And that gives me positive 1. So, in essence, what that is, if I drew a graph, an x-axis, and if here was 0 and here was 1, if I plotted the points on the graph of y equals x cubed plus 2x squared minus x minus 1, at 0 I get negative 1. Okay, so there's my plotted point. At 1 I get 1. So there's my plotted point, which means if this is a continuous graph, then when we join up those two values, then the graph goes through the x-axis, so the y-coordinate is 0, between 0 and 1. So there is some value there between 0 and 1. I don't know quite where, and that is the value gamma. So that's what a sign change means. It means that we have a change in sign, from one being negative to the other one being positive, which means that we've gone through 0 between them. Okay, so we just need to state that there is a change of sign. So I'm just going to write change in sign. Great. Now what we're going to do is we're going to find the value of gamma by using iteration. So part B is leading us towards the iteration. It's finding a way of rearranging x cubed plus 2x squared minus x minus 1 into a new way of writing that. So x cubed plus 2x squared minus x minus 1 equals 0. I need to rewrite it as x equals the square root of x plus 1 over x plus 2. Okay. Well, the x plus 1 might be gained by just simply adding x and adding 1 to the other side. So I'm going to try that. X cubed plus 2x squared equals x plus 1. Now, I want to get x plus 1 being divided by x plus 2. So maybe if I take a factor of x plus 2 out of the left-hand side, and if I do, I get x squared. And that's quite helpful. Now my next line is going to be x squared is equal to x plus 1 over x plus 2. And therefore, x can be written as the square root of x plus 1 over x plus 2. QED. Okay, so that's us showing that that is a rearrangement of the equation. So all I've done is using algebra to rewrite that in that form. Okay. Now it says using the iterative formula, and if you want some more input as to what an iterative formula means and where it comes from, then please see my lesson on this, which I'll explain to you in a second which number that is. So using the iterative formula, xr plus 1 is equal to the square root of xr plus 1 over xr plus 2, with x0 equals 0.8. So x0 is like the 0th value of x. Iteration, we substitute in an initial value for x, and we keep repeating the process, and it gives us our next value and our next value and our next value. So if we use 0.8 as our 0th value, we will use that to find our x1 value, our first value. And then we will use our first value to find our second value, etc. Okay, so I'm going to use x0 to find x1. So I'm going to find x1 by doing the square root of the 0th value plus 1 over the 0th value plus 2. So that will be the square root of 0.8 plus 1 over 0.8 plus 2. And then I just use my trusty calculator, and that gives me 0.801783 ... Okay. Then I keep that on my calculator, and I use that to find my second term. So I just simply, to find my second term, I need to use the previous term, so I need to use the first term plus 1 over the first term plus 2, and then square root that. And that, if I plug that into my calculator right, is 0.801925 ... So it's not changed very much. And then I'm going to use that again to find my third value. Okay, so I'll plug that in and add 1 over, plug that in and add 2 and square root the whole thing. And that will give me 0.801936 ... Okay, and the fourth value, 0.801937 ... So not much change. In fact, if I keep going, soon you won't be able to distinguish between numbers. If you keep, if you put instead of keeping on typing the next number fully out, you type in answer plus 1 over answer plus 2 all square rooted, and press equals, it'll just substitute in that previous value in as the next value. And eventually you start seeing that it becomes 0.8019377358. And it doesn't seem to change very much. And since we only want to find the answer to 3 decimal places, then it seems like the value of x seems to be 0.802. So that's our value of gamma, 0.802 to 3 decimal places. Since this number here seems to be the answer, and that rounds to 0.802. Okay. If you want more practice on locating roots with the sign change rule, that's lesson 31, and iteration, that's lesson 32. Okay, let's have a look at question 10. Again, if you haven't had a go at this question, have a go at it before we go through it. So we're given that the line y equals 2x plus k cuts this circle x squared plus y squared equals 5 in 2 points, A and B. Okay. Show that the x coordinates of A and B satisfy this equation. So if I'm trying to find out where two functions meet, then I need to solve them simultaneously. Here I've got a linear function and a non-linear function. So I've told that y is equal to 2x plus k. So if I simply substitute that in instead of the y in the non-linear function, I will find the solution of where those two are correct. So that gives me x squared plus, instead of y squared, I'm now going to have 2x plus k all squared equals 5. Now I'm going to expand that. So I get x squared plus 2x plus k all squared means 2x plus k times 2x plus k. So I'm going to expand that. 2x times 2x is 4x squared. 2x times k and 2x times k again gives me 2xk, and 2xk gives me 4xk or 4kx. And then k times k gives me k squared. And that equals 5. Then if I subtract 5 from both sides, I get, and combine the x squared and the 4x squared to give me 5x squared, I get 5x squared plus 4kx plus k squared minus 5 equals 0. And that is what it says here. It's just that they have put a bracket around the k squared minus 5 for reasons that will come clear in part B. Okay, so it says, hence find the values of k for which the line is a tangent to the circle. So I'm just going to sketch out the circle. So the circle will look something like this. This will be a terribly drawn circle, I imagine. There we go. It wasn't as bad as I thought. X squared plus y squared equals 5 will be a circle with a center at 0, 0 and a radius of root 5. So it'll go through at root 5 there, and at each intercept will be either root 5 or negative root 5. Y equals 2x plus k has a gradient of 2, so it'll be a straight line with a positive gradient, and if it's a tangent to the circle, a straight line with a positive gradient of 2 will either be a tangent to the circle over there, or it'll be a tangent to the circle on the opposite side of the circle just there. Okay, so those are my two options. That's what it'll sort of look like. Okay, sort of like a TIE fighter in Star Wars, but with infinite wings, because they would keep going on. Anyway, a tangent to a circle only hits the circle once. Instead of having two coordinates where it says A and B, it'll have one coordinate where it meets. If there is only one solution where they meet, then this thing from part A, which is a quadratic, with a k being just some constant that we don't know, that quadratic, instead of having two solutions, it will only have one solution. Okay, so I'm going to rewrite that quadratic out again. 5x squared plus 4kx plus k squared minus 5. If a quadratic has one solution only, then the quadratic formula, the discriminant, the bit underneath the square root, will equal 0. So the b squared minus 4ac part will equal 0. Here, my a is 5, my b is 4k, and my c is the bit in brackets. It's the k squared minus 5. So the discriminant is b squared minus 4ac. That will equal b squared, 4k times itself will be 16k squared. Minus 4 times a times c. So that's minus 4 times 5 times k squared minus 5. And that simplifies to 16k squared minus 20k squared and plus 100, if you multiply that out correctly. I know that discriminant is equal to 0. I'm going to simplify that a little bit further. 16k squared minus 20k squared is negative 4k squared. Plus 100 has to be equal to 0. Add 4k squared to both sides, you get 100 equals 4k squared. Divide by 4, you know k squared has to be 25. And if k squared is 25, then that means that k could be 5 or minus 5. So there are two values that are possible for k. And that makes sense because if we look at our TIE fighter, either we've got the left side and that would cut through the y-axis at some positive value of k, or we have the right side which will cut through the y-axis at some negative value of k. And we found out that those values are 5 or minus 5. Okay. And the question asked for the values of k, and we found those, 5 or minus 5. Okay. So that's the mark scheme. If you want some more practice on the equation of a circle, have a look at lesson 10 in my channel. Okay. So that's questions 1 to 10. The next video I create will be for questions 11 onwards, okay, which is the next 50 marks of the paper. All right, but have a go at the questions before you come and have a think about how to do the answers. Okay. All right, good luck.